Question 34. Which alkene on addition of H2O can produce only one alcohol? So we know that adding H2O to an alkene, this will be the addition reaction where the double bond between two carbon atoms will open up into two single bonds, and on each bond, hydrogen atom will be added on one and the hydroxyl group will be added onto the other. So for this question, we need to draw out the final product of each of the molecule on addition of a water molecule. So for compound A, the structural formula will look something like this. And we can see that there are two different positions to which each of the group can be added to. For example, in the first product, hydrogen can be added to the second carbon, leaving the hydroxyl group to be added to the third carbon. However, these two groups could also be swapped, where the hydroxyl group is added to the middle of the second carbon instead, and the hydrogen atom is added to the third carbon. These two compounds are isomers because the hydroxyl group is located on different carbon atoms. Therefore, compound A will produce two different alcohols, and A is not the correct option. Let's try to draw the same for compound B. The structural formula of compound B should look something like this, with the double bond on the third and the fourth carbon atoms. Upon addition of a water molecule, the hydrogen atom could be added to the third carbon atom and the hydroxyl group added to the fourth carbon atom. Or the opposite could occur, where the hydroxyl group is now added to the third carbon instead of the fourth, leaving the remaining hydrogen atom to be added to the fourth carbon atom instead. Again, these are two different products because they are isomers of one another, where the hydroxyl group is located on different carbon atoms. Therefore, for B, two products or two alcohols can be produced, and B is not the correct option. For compound C, similarly, two products can be formed upon addition of a water molecule. The hydrogen atom could be added to this specific carbon, leaving the hydroxyl group on the second carbon. Or the opposite could have occurred, where the hydroxyl group is added to this carbon instead, leaving the hydrogen atom to the second carbon. These are again two isomers of the same alcohol, hence C is wrong because it does not produce only one alcohol. In compound D, we see that there is actually a line or a plane of symmetry in this compound. Therefore, if hydrogen were to be added to the first carbon of the carbon double bond, versus if it were to be added to the second carbon of the carbon-carbon double bond instead, here, leaving the hydroxyl group to the other carbon, we realize that these two compounds are exactly the same. We know this by flipping one of the compound laterally. We can see that we will get the first compound. Therefore, two of these are the same compound and they are not isomers of one another. Therefore, D is the only option in which the alkene can only produce one alcohol upon addition of the water molecule.